हो गया, आ गया है।
हाँ
तो मैं तो हेलो लिख दूँ।
हाँ, यहाँ से आप चार्ट करके अपने स्टूडेंट ऑनलाइन में
पार्टिसिपेंट्स है ना।
डियर पार्ट्स become
इसका ले लिया है, हमने ले लिया है।
सर आप कोर्स पे कुछ जनरल ऐसे इंट्रोडक्शन स्टार्ट कर सकते हैं।
लिख के ही ना,
नहीं,
बोल के।
हाँ स्टूडेंट तो आपको सुन सकते हैं।
कितने हैं इसमें पता लगेगा यहाँ पर? 0/200 लिखा है।
5 जैसे
5 आ गए हैं, कहाँ पर है?
वो एजुकेशन
वहाँ पे
हाँ इससे नीचे पढ़ो।
कॉलेज में
So dear participants, I hope the course is running okay. You are comfortable with the content of the course, and today we have the interactive session live, so you can opine about the course, the how you are taking this course, how you are feeling about the content of the course, what are the problems if you are facing, or the reference materials. So we will have some discussions on these things in today's interactive course, interactive session. So this was a 12-week course, and it's about the welding metallurgy. So I'm quite feeling good to see that you will be interacting with me. We will have some interactions. See, Nix 073, so you are asking that does weldability only depend on hot cracking and cold cracking? In fact, weldability, as you see, weldability is defined in a very rough manner as the ease of welding, so that you don't get any defects. So there are many kind of defect except the hot cracking as well as cold cracking. So you cannot say that it is only depending upon the hot cracking and cold cracking. So anyway, either the any kind of defect should not come. If it is purely weldable, it should be easily done. So you cannot say very firmly that it is only upon the hot cracking as well as the cold cracking. There are many other issues, like there should not be the blowholes, the gaseous porosities, or shrinkages. The apart from the cracks, you have many things. So you will have improper profile. So all these different type of defects are likely to come. You also know that when you go for welding, then in many cases you have to provide a shielding environment. So in the absence of that, there may be a lot of large amount of defects may occur, large varieties of defect may occur. So we can say that it will depend upon overall weldability is it's a term which will be depending on many factors. Hello Arun Kumar, welcome to this session. Thank you, Mr. Edson Capanos Silvera. So it's also nice to have a good response from your side. So unless we get good response, and of course we will not be successful. So for that only we are here to give you a good service, a good teaching material. And also interacting with you. So that time has come, and we should do that. There are certain queries that I have got, and that is from Nitesh Krishnan. So he is a student, and he has written that he is a student, and as we are coming live at 3 to 4, how can I interact with you while I am inside the classroom? So when you are inside the classroom, you can write the queries, and you can have the discussion on that. So then another defect, see what is the worst defect in welding of carbon steels and high carbon steels. That's what Edson Capono Silveria. So in these cases you have in the case of carbon steel or high carbon steel, when you have high carbon steel, as you know that when the carbon is becoming more, in those cases the weldability will be decreasing, and as you go towards the higher carbon side, so you need to have the control on the cooling rates, control on and that's why you have a pre and post weld heat treatment is available. So what is the worst defect that will be, defect we can have, any degree of defect, if it is to higher degree, it will be worst. So, defect up to certain extent in some cases, in some cases defect even in a smaller way also is quite deleterious. But all the kind of defect which you see, so like in the case of these steels, you will have the defects will be like there may be warpage or so those challenges are there. So there may be distortion. So that kind of defect may be there. When we talk about those steels, and if we have the alloying elements also, then the chances of the loss of alloying elements are also there in those cases. Now, I have got one query that whether these post-weld heat treatment have any effect on the 304 austenitic stainless steel welding. So, as you see that these mostly these austenitic stainless steel weldments, so they will not require these post-weld heat treatments. So, and for those that do, the heat treatment temperature has to reflect the concern which has to be addressed. So, any type of heat treatment of these austenitic chrome nickel steel weldments, it will be depending mainly on the service conditions. So that is normally there with the austenitic steels, and also many a times we give a certain heat treatment, so that is for improving that certain degree of corrosion resistance possible, like we may give the solution treating. So that may be given, so that you can homogenize or stabilize. So those kind of heat treatments are normally given, so that the exposure to the highest temperature, that is avoided. So the heat treatment can be used for stress relieving purpose in those steels. So that will give you more dimensional stability in such cases. Or again, we can reduce the stress corrosion cracking also. So normally they have these austenitic stainless steels. So as we have talked about its traits, its qualities, they have low thermal conductivity, and they have high coefficient of friction. So coefficient of expansion, sorry. So and they have good elevated temperature, mechanical strength. So in the thick materials, they can be subjected to that high internal stresses. So that's why you need to give the PWST. Okay. Now next is from the Ankur Tumar. So he has written that I am cladding nickel-based alloy on SS 304 by pulse GMAW process at 150 ampere, but there is a lot of cracks on the weld. How can it be prevented or reduced? So cladding, as you see, this is process. So you are cladding this nickel based alloy on the SS304, and you are using the pulse GMAW. So what you have to see that see cracks why they come when you do the cladding. So maybe because of the difference in the surface expansion property, there may be cracks, or there are other reasons. Normally cracks, as you know, these cracks are because of the result of the stresses. So you will have to have a look at the temperature at which both these sheets are maintained. So by having a control on that, there may be minimization or prevention of these cracks. So as you know that because you have these dissimilar materials, so and also as you have told, you have given the process parameter value, that is you have taken the this 150 ampere value. So that is giving you the crack. Have you taken have you seen the effect of changing the current? So that may give you a certain idea about this, that what will be its effect. So one thing is that, and then maybe whether you are also doing some preheat. So can you please give me the idea about the preheating also? Are you going for the preheating of the material also for these two? In between, we have the other queries. So another query is is this session the first live session? So it is certainly first live session. Then Praveen Vengara. So he is writing that in practical, what are the main aspects of choose the welding electrode for a specific material? So yeah, Ankur, what I feel that see these cracks mostly, as you see that you have two different materials, you are welding them, and they are heated and then they are cooled, so their expansion rates are different. So it may be one of the reasons for the cracks, and you will have to suitably choose the temperature of maybe by preheat. So as you know, depending upon the conductivity and all that, many things difference. So those values are required to be kept in mind. Then you have so one question is about the main aspects to choose the welding electrode for a specific material. So as you know that when you go for the welding, and you have to choose a welding electrode, at that time you have some aspects which is coming is which is important is the thickness of the material which you are welding, then the type of material which you are welding, and the flux, because there are many things as related to the welding electrode, because in the welding electrode you have if you are talking about the coated electrode, in that case, you have the in the center you have the bare wire, and that is coated with the material that is flux. So that also is of different type, and depending upon the kind of welding, like with related relate to the you know with relate to the position, like you are doing vertical welding, or you are doing the horizontal welding, or you are doing the overhead welding. So these are the things based on which you are going to have the selection of the electrodes, and typically you will have to have because it has to carry the current, and then it has to melt, and deposition rate is another thing which is has to be taken in mind. So these are the points which you need to have in mind while doing the welding. What is the worst defect? So again, Edson Copano Silveria. So he is Mr. Silveira is asking that what is the worst defect in welding of carbon steel and high carbon steel? How to prevent it? So as we have discussed, that the defects can be because of many reasons, and one is because of the when you are working, you are not taking care of. There can be defects related to shrinkage. There can be defects related to distortion. So and there can be also defects related to carbide formation. So you have more carbon if you are alloying elements, so that also may form the carbide. So you may have undesirable phase formation. So so all these things, so that you have to have that in mind. Now, in case of the high carbon steel, so it has its weldability is poor because of the their high hardenability and susceptibility to cracking. So you are writing, Ankur Kumar, will cracking increase or decrease with increase in heat input during welding, especially solidification cracking? Now you see, if you look at the this cracking, so this is a very one way it's a relative term. So if the cracking is because of the temperature, the gradient which is set up. So how quickly the heat is to be transferred, or how the temperature gradient is developed. So cracking will increase or decrease with increase in the heat input during welding, especially the solidification cracking. So as you see this, if you are doing the heat input increasing, so the solidification will be delayed because the temperature will be high, and in that case it will not be it's not going to be advantageous in that sense. So so that is the because the heat input, if you are doing the heat input, so for that heat input, when you are increasing, that is normally for so that has to be balanced with the welding speed. So that is one thing. And if you talk about the solidification cracking, so that is done when it is hot, basically. So certainly heat, if you have the increase in heat input, that will affect it. Now we are talking about these high carbon steel. So in that you require to have the in that the main challenge is the formation of the martensite, because you have large amount of carbon, and that will try to have promote the formation of martensite in those cases. So that is the challenge in these cases. So you will have to have so main problem is related to the formation of these undesirable phases, and also the stresses which are developed. So you require to be to annihilate. So annealing is normally recommended for high carbon steels. Then you have certain many steel certificates are restricted to soaking time for post-weld heat treatment. That means if certificate allowed 2 hours, we can do 1 hour for PWS steel. For 2 time, I am talking about repair aspects. If one more cycle is required due to repair, it does not allow. Why the PWS soaking time is restricted? Now many a times that so we will talk about it. So this is about the restriction to soaking time for post-weld heat treatment. Now certainly if you are doing anything for a larger time, so that may lead to the cases like annealing. So it may be softening certain phases, so that may have undesirable effect. So that will be there in those cases. And then we have the why the weld dissimilar welding. What are the main aspects to consider this sound weld? What chemical and mechanical properties considered for selection for electrode? So when we are doing the dissimilar welding, now in these cases, the thing is that there has to be proper diffusion at the surface. So they must diffuse, and you will have to have if you are using the any electrode, so that electrode has to be suitably taken, which should be forming or gelling equally well with these two parent materials. And the main when the main aspect which is considered when we are talking, because we have to see that what are the properties of these two materials which you are welding. If their property vary very much, it will its welding will be that way difficult. So you will have to have these aspects to be kept in mind, and maybe in those cases you will have to go for the proper pre or post weld heat treatment process to be adopted, so that there is no undue stresses formed, and that may which may further result into undesirable phases or the emanation of different kind of welding defects. So these are basically the challenges when you are doing the dissimilar welding. In the case of dissimilar welding of that is welding of two dissimilar materials, and you will have to have many properties to be kept in mind, like the surface tension effects maybe at the surface. No, they are not that very important. However, the what kind of coating you are using. So normally you go for if you are using that coated electrode. Otherwise, you have to see that the proper there should not be undesirable phases which should be formed or intermetallic, which should be detrimental for the mechanical properties. So then this is what that. Now this is you are talking about the one more is will there be any effect of heat treatment on weld overlay? So as you see that it is weld overlay or hard facing. So in terms of micro hardness, wear resistance, and dilution. So this weld overlay, as you see that it will have one or more metal with specific characteristics. They are applied to the material, to the base metal, and you have to so that original dimension is so we also call it as a cladding or hard facing or so. Now if you look at the weld overlay, so you are knitting that a coating, that welder, it will be so you will have so you have asked that in terms of micro hardness, so what will be the effect of the heat treatment? So when you do the heat treatment, now heat treatment will may have effect on the surface. So if you are going for the surface type of treatment or wear resistance, dilution. So certainly, as you see, you can give a proper heat treatment to increase the wear resistance, because the wear resistance you require the higher resistance or to wear at the surface, and if you give some kind of heat treatment, in that case the surface. But weld hard facing, when you talk, you are making that surface itself hard, and if you give any heat treatment, in that case especially the surface heat treatment or the diffusion of certain metals, certain material into the surface, which makes it further hard, so that may affect the wear resistance or the micro hardness of the material. So this is because there has been work on the effect of heat treatment on the weld overlay or the weld harvest components, and especially the there has been it has been reported on the residual stresses and the mechanical properties of the material, and there is effect which is reported, so that can be, you may have the post weld heat treatment also, and there will be effect. So, you are selecting iron base, so Nikhil Pandya, so you are selecting the iron base metal, and cladding material is some cobalt base or nickel base. So what will be the effect in diffusion of elements? So basically that will be depending upon the conditions. So because this cobalt or nickel, so you are having these cobalt or nickel we normally use as the so they will be making these surface. They are normally used for improving these properties of the surface. And as far as the diffusion is concerned, so diffusion will be depending upon at what temperature you are doing. So diffusion normally will be depending upon the working temperature at that temperature, which because the diffusion will be controlled by that parameter. Diffusion of elements, diffusion of elements in what sense? Cobalt base or nickel base, so we need to have. So what will be the effect in diffusion of elements? So basically you are doing with that, and you will have a cladded layer, and it will give you a specific material, but that will be depending upon the conditions under which you are doing that work. So also these there will be values for the activation energies, and you will have the different temperatures. So for the different temperature, so after heat treatment, if any change in dilution, no, see, you are doing the heat treatment. Heat treatment is normally done to do the stress relieving and all in these cases. So that is the main reason in these cases. So normally PWST post-weld heat treatment is has been suggested, and it has been reported, and that will be not changing much in these values. So otherwise, you had another question that we discussed, that differs defect in welding of carbon steel and high carbon steel. Normally, the formation of undesirable phases. Welcome. Okay. And in case of the carbon steels and high carbon steels, you will have the main challenge is related to the formation of the modern steel phase, which will make the product less suitable for the application. So that is the main defect, and apart from that, there may be the warping and other related defects may also occur. What is the effect of rolling direction and tensile strength of steel? That is asked by Praveen Vengra. So, Praveen is asking that what is the effect of rolling direction and tensile strength of a steel? So, if you see, if you do the rolling in a particular direction, so if you are drawing the, having the rolling, suppose in a in whatever direction, so that basically those fibers or grains are oriented in that particular direction, and along that direction, if you do the tensile testing, so the tensile strength will certainly be more as compared to the transverse direction, because because of there will be tearing effect, you will have so normally the tensile strength will be more in one of the direction, that is along the stretch or the elongated fiber direction, and it will be lesser in the transverse direction. So that is normally the effect of rolling on the tensile strength. Thank you, Edson. So it's nice that because see there is no limit to study. More and more you study from the different sources, or if you are a practicing engineer, you will have more cases coming up. So this this domain of in this domain you will have every day some new, you can have new observations, you can have new cases. What we study normally are the theoretical aspects first, and then we also deal with some case studies. But most of the things will come as you do the practice, as you go for the experimental work. So many things, many challenges come, and that's how you learn. So normally, if you are into this, domain, if you are in an industry, or in that case, you must be having many new things, And as far as the material is there, you should refer good books, that gives more and more case studies and examples, so that will be more helpful for you. That's what I feel. Now, one of the things, certain part initially we talked about the physical metallurgy part, and then we also had the discussion on the heat flow. So there you have some numerical exercises also. So and then we talked about the zone involvements, and we talked about the weldability defects and all. So certainly it's there are many topics, and if you study them properly, it will be mostly used whenever you do the welding. So basically it has all those chapters where from you can start. So suppose you are talking about when we are studying about other welding courses, so in those courses you require the information about these basic things. So just like you have the design, or you may have even the quality control or so. So you have a suggestion that the pointer used by you is very small. Sometimes it is not divisible. So is it in that I think you are talking about that live course which was running? And there certainly that pointer was small, so normally I try to use the mouse also, but we will look into it that we use that pointer. Thanks, Nikhil. So, as I was telling that you will have the initially you talked about some material science, and then we talked about the heat flow. So from the heat flow side, we talked about the stress and distortion. So that itself is a domain where many work can be done. We talked about the weldability. We talked about other aspects also. Thank you, Adun Kapano Silvira. Thank you very much for your interest in the course, and I hope that you will be benefited with this course. So human 8 minutes. We have 5 minutes. If you have any other query related to the course, you can suggest for the improvement. You have tried to give explanation to the queries which have been raised, and there have been good questions which has been framed by the students and participants. So we are coming closer to the end of this session, and I wish good luck for the course, and I also wish good luck for those who are appearing for the exams in the future. So you need to study those materials which have been mentioned in the classes, and I hope that you will do well if you are going through them and also referring to the textbooks to study that particular domain in the long run. It will be helpful for you for your professional achievements. That's what I wish for all of you. So thank you very much for attending this session. Thanks a lot. And